Hello, mathematicians. Today we're going to be learning about systems of linear inequalities. Before we get started, we're going to do a quick review. So, linear inequalities are very similar to linear equations. We even graph them almost the same. However, in linear inequalities, we have an inequality instead of an equal sign. So we'll have equations with greater than, less than, greater than or equal to, or less than or equal to signs, as opposed to just an equal sign. If we have a linear inequality with a greater than or less than sign, then we're going to draw a dashed line. On a dashed line, if there is a coordinate, that means that that coordinate is not a solution to our inequality. However, the coordinate on a solid line is a solution to our inequality. So here we have two inequalities. Y is less than 2x minus 7, and y is greater than or equal to negative 3x plus 8. So we're going to graph one at a time, and we're going to start off with y is less than 2x minus 7. So in order to start graphing that, we're going to plot the Y-intercept. So the Y-intercept is negative 7. So on the y-axis, we're going to plot negative 7. And since our slope is 2, we could rewrite it as 2 over 1 to help us with the rise and the run. So starting at negative 7, we're going to go up 2 units and go to the right 1 unit because our slope is positive. So our rise is 2 and our run is 1 because 2 over 1 is the same thing as just 2. So after we have a few coordinates in, we could draw a line through our points. And before we move on to our next inequality, we're going to shade first. So the easiest coordinate that we could use to shade is we could use 0, 0. So if 0, 0 is true, then we're going to shade the left side. If it's not true, then we're going to shade the right side. So if we substitute x and y for 0, 0, we end up with 0 is less than 2 times 0 minus 7. So we end up with 0 is less than 2 times 0 is 0 minus 7 is negative 7. So we end up with 0 is less than negative 7, which is not true. So instead of shading the left side, we're going to shade the right side since we know that this left side is not true. Now, you could check another coordinate just to be sure, but we could see here that after we simplify this inequality, this is not true. So we're going to shade to the right side of this line. And it'll look just like that. And remember that we're able to use 0, 0 because this line does not fall on 0, 0. If it does, then you have to pick another coordinate. So our next inequality is y is greater than or equal to negative 3x plus 8. So we're going to start off by plotting our line. So we're going to start off with our y-intercept, which is 8. And we're going to go over to the y-axis and plot it at 8. So our y-intercept is 0, 8. And then in this case, because our slope is negative, instead of going up 3 units, we're going to go down 3 units. So we're going to go down 3, and then we're going to go over 1. Same thing, we're going to go down 3 over 1. Down 3 over 1. And so here I have more than enough coordinates, so I'm going to draw my line through it. And now because its y is greater than or equal to, then our line has to be solid this time. All right, and so same thing, since our line does not cross 0, 0, we could use it as a coordinate to test to see if our inequality is true at 0, 0. So we're going to substitute y and x for 0. So we end up with 0 is greater than or equal to negative 3 times 0 is 0, and 0 plus 8 is 8. So 0 is greater than or equal to 8, which we know is not true. So we're not going to shade to the left side. We're going to shade to the right side of this line. And so once we shade it, it looks like that. And because we have two inequalities here, you'll notice that we shaded for our first inequality, which is in red, and then we shaded to the right. And then we plotted our second inequality, which is in blue, and we shaded to the right. And now because this is a system of linear inequalities, the shading that they both have in common represents that these coordinates are true for both these inequalities. So if I were to pick a point, a coordinate in this blue area, that would only be true for my second inequality. If I were to pick a coordinate in this red area, that would only be true for my first inequality. However, if I pick a coordinate in this purple area, then this coordinate is true for both inequalities, making this purple region the solution that is true for both inequalities. So when we're doing systems of inequalities, we want to find out which coordinates are true for both inequalities, which is this purple region here. So next we have y is greater than or equal to 1/4 x plus 2, and x is greater than negative 4. So we're going to do the same thing. We're going to graph one inequality at a time. And we're going to start off with our first inequality here. So y is greater than or equal to 1/4 x plus 2. And in order to graph this, we're going to start off by plotting our y-intercept first. And since our slope is 1/4, 1 is our rise, so we're going to go up 1 unit, and then 4 is our run, so we're going to go to the right 4 units. So 1, 2, 3, 4, and we're going to do that a couple more times. And this is more than enough. So we have four coordinates here, and because it's y is greater than or equal to, then we're going to draw a solid line between these coordinates. And so once I have my line, I'm going to see which region I should shade. So if I should shade above or below this line. And again, the easiest coordinate that we could use is 0, 0. So using 0, 0, we're going to substitute in for x and y. So here we end up with 0 is greater than or equal to 0 plus 2, which is just 2. And we know that that is not true. So we're not going to shade the area with 0, 0. We're going to shade above that line. And we could also shade that in red to match our line. And so now we're going to graph our second inequality, which is x is greater than -4. And we know that if this were x is equal to -4, we would just draw a vertical line, and we're going to do the same thing here since it's an inequality. And because it's x is greater than, we're going to draw a dashed line. And since x is greater than, all the numbers that are greater than -4 are to the right of this line, so we're going to shade to the right side. So again here, if I plot a coordinate on this red area, that is only true for my first inequality. Any coordinate in my blue area is only true for my second inequality, but any coordinate in this purple region is true for both inequalities. So if we were to take this coordinate and test it out, it would be true for both inequalities. So this shaded area here is true for both inequalities, and it's our solution to our system of linear inequalities. So here we have two linear inequalities again. And same thing, we're going to plot one at a time. And so for my first inequality here, we have y is greater than -4x plus 3. So we're going to start off by plotting this. So we're going to plot our y-intercept, which is 3. So on the y-axis, I'm going to plot 0, 3. And then because our slope is -4, we're going to go down 4 units. So 1, 2, 3, 4, and then 1 to the right. And then we're going to do that again. So 1, 2, 3, 4, and then 1 to the right. And so here I have 3 coordinates, which is more than enough. Because it's y is greater than, we're going to use a dashed line. Let me make that red. And now to figure out which side we should shade, again, we're going to use 0, 0 to help us. So y is greater than -4x plus 3. So we're going to substitute y and x with 0. So -4 times 0 is 0 plus 3. So 0 is greater than 3, which we know is not true. So we're not going to shade to the left of this line. We're going to shade to the right. And now we're going to plot the second inequality. And this inequality here is in standard form. So in order to plot it, we have to find our x and our y-intercept. So in order to find, we could start off with our y-intercept. In order to find our y-intercept, we have to substitute x for 0. which actually crosses this out because 2 times 0 is just 0. So minus 3y is less than or equal to negative 12. And now we're going to solve for y. Divide both sides by negative 3. And y, because we're dividing by a negative, our inequality sign flips. So y is greater than or equal to negative 12 divided by negative 3 is positive 4. So here our y-intercept is 0, 4. And now we're going to find our x-intercept. So very similar, but this time we're going to substitute our y for 0 in order to find our x-intercept. So 2x minus 3 times 0. This ends up canceling out because that's just 0 is less than negative 12. So we end up with 2x is less than or equal to negative 12. Divide both sides by 2. X is less than or equal to negative 6. So our y-intercept is negative 6, 0. And because we have less than or equal to, we're going to draw a solid line. So in order to know which side we should shade, again, we're going to substitute x and y for 0, 0. So 2 times 0 minus 3 times 0 is less than or equal to negative 12. So that ends up being 0 is less than or equal to negative 12, which is not true. So we're not going to shade to the right of this line. We're going to shade to the left of this line. Okay, so again, if our coordinate is on the red region, then that's only a solution to the first inequality. If our coordinate is in the blue region, then that's only a solution to our second inequality. But if our coordinate is in this purple region, then that's a solution to both inequalities. Here we have two more inequalities. We have y is less than or equal to negative 3 over 5x plus 1, and y is greater than 2. So we're going to start off with plotting our first inequality. So y is less than or equal to, so we know that that's going to be a solid line. Negative 3 over 5x plus 1. So we're going to start off by plotting our y-intercept at 0, 1. And because our slope is negative, negative 3 over 5, we're going to go down 3 units, 1, 2, 3, and then we're going to go to the right 5. 1, 2, 3, 4, 5. And then again, 1, 2, 3, 1, 2, 3, 4, 5. So we have 3 coordinates here, so that's more than enough to draw our line. Let me just change that to red. All right, so once we have that line plotted, all we have to do is test our coordinates. And again, I'm going to use 0, 0 since that's the easiest coordinate that we could use. So y is less than or equal to negative 3 over 5x plus 1. And now we're going to substitute our x and our y for 0. So 0 is less than or equal to negative 3 over 5 times 0 plus 1. So 0 is less than or equal to negative 3 over 5 times 0 is 0, plus 1 is just 1. So here we have 0 is less than or equal to 1, which is true. So we're going to shade the side with 0, 0. And so now we have y is greater than 2. And we know that that's a horizontal line, so we're going to plot it as we normally would if it were a linear equation. And because it's y is greater than 2, we're going to use a dashed line to represent that. And now we know that all numbers that are greater than 2 are above this line because here we have 3, 4, 5, 6, 7, 8. So we're going to shade above. So remember that any coordinate that is on this red region is a solution to our first inequality. Any coordinate that's in this blue region is a solution to our second inequality, and any coordinate that is in this purple region is a solution to both inequalities. All right, so here we have one more example, and both our inequalities here are in standard form. So in order to graph them, we're first going to find our x and our y-intercepts. So for my first inequality, I have x minus 2y is less than or equal to 4. And in order to get our y-intercept, we're going to substitute x for 0. So once we do that, we could really just cross that out. Minus 2y is less than or equal to 4. So we end up with negative 2y is less than or equal to 4. In order to get y by itself, we have to divide both sides by negative 2. Negative 2 divided by negative 2 cancels out. So we're left with y is greater than or equal to negative 2. So our y-intercept is negative 2. All right, so we're going to do the same thing to get our x-intercept, but this time substitute our y for 0. So x minus 2 times 0 is less than or equal to 4. And we know that this cancels out because it's just 0. So x is less than or equal to 4. So our x-intercept is at 4, 0. And because our inequality is less than or equal to, we're going to use a solid line. And now we're going to test our coordinate. We're going to use 0, 0. So we have x minus 2y is less than or equal to 4. And if we do substitute 0, 0, we get 0 minus 2 times 0 is less than or equal to 4. And we end up with 0 is less than or equal to 4, which makes this true, so we're going to shade the side with 0, 0. All right, and now we have negative 3x plus 2y is less than or equal to 6. And we're going to find our x and our y-intercept. So in order to get our y-intercept, we're going to substitute x for 0. So negative 3 times 0 plus 2y is less than or equal to 6. This cancels out. So 2y is less than or equal to 6. Divide both sides by 2. Y is less than or equal to 3. So our y-intercept is at 3. And now we're going to find our x-intercept. So negative 3x plus 2y is less than or equal to 6. And now we're going to substitute y for 0. So negative 3x plus 2 times 0 is less than or equal to 6. So this cancels out. We're left with negative 3x is less than or equal to 6. If we divide both sides by negative 3, we get x is greater than or equal to negative 2. So our x-intercept is at negative 2. And because it's less than or equal to, we're also going to draw a solid line again. And now we're going to test out our coordinate. And now we're going to use 0, 0 again. So negative 3x plus 2y is less than or equal to 6. And we're going to substitute x and y for 0. So negative 3 times 0 plus 2 times 0 is less than or equal to 6. And so we end up with 0 is less than or equal to 6, which is true. So we're going to shade the side with 0, 0. And so again, if our coordinate is in the red area, then it's only a solution for our first inequality. If it's in the blue area, it's only a solution for our second inequality. But if our coordinate is in the purple area, then it's a solution for both inequalities. And that's it.